Hello, as we all know that oil plus water will give us emulsion. Therefore, emulsion is grouped into two types, oil in water emulsion, water in oil emulsion. The example for oil in water emulsion is milk, whereas for water in oil emulsion, it's butter. But how do we maintain emulsion like milk? We can maintain the emulsion with the help of emulsifier. What is an emulsifier? When oil and water are mixed together by stirring, it will form an emulsion, but they will break once the stirring motion stops. An emulsifier is a surface-active agent added to adsorb to interface and stabilize the emulsion by preventing it from separation. Emulsifier contains both hydrophilic and hydrophobic site, which allows them to bind to both hydrophilic and hydrophobic molecule, consequently allow the two immiscible liquid to be mixed by lowering the interfacial tension. So, what is interfacial tension? It is a force needed to hold the surface of a particular phase together. Examples of interfacial tension are liquid-liquid interface and liquid-solid interface. Now, let's move on to what control the stability of emulsion. Interfacial surface forces, size of dispersed phase droplets, viscous properties of continuous phase, and density difference between two phases. Interfacial surface forces. The two main interacting forces affects the emulsion systems are van der Waals attractive forces and electrostatic repulsive forces. Attractive forces tend to destabilize emulsion, whereas repulsive forces generally impart stability into the emulsion. Size of dispersed phase droplets. An example of oil in water emulsion, the oil droplet is dispersed phase. It has to be as small as possible to prevent from calcifying as colloidal dispersion. It is due to the influence of gravity and the difference in density between the two liquids, oil droplets will tend to rise to the top and cause emulsion instability. Viscous properties of the continuous phase. The higher the viscosity of the continuous phase, the more stable the emulsion will be. Lastly, density difference between the two phases. The closer the similarities of the densities of the two components, the separating effect of the gravitational forces will be lesser. Moving on to types of emulsion instability: creaming, sedimentation, flocculation, coalescence, and phase inversion. Creaming. It is a process which droplets move upwards, where droplets' density is lesser than the density of continuous phase. Sedimentation. It is a process in which droplets sink to the bottom, where droplets' density is more than the density of continuous phase. Flocculation. It is a process in which two or more droplets clump together to form an aggregate. However, the droplets still retain their individual integrity. Coalescence. It is a process in which two or more droplets merge together to form a single larger droplet. Lastly, phase inversion. It is a process in which oil in water emulsion changes to water in oil emulsion or vice versa. However, here we are going to focus on sedimentation. Now, milk is an example of oil in water emulsion. But what about chocolate milk?
So, do you know how chocolate milk is made? Chocolate milk is actually made with cocoa powder with milk. There are two types of chocolate milk shown. Do you spot the difference? That's right, one of them has sedimentation. In this case, chocolate milk is actually solid in liquid emulsion. The dispersed phase is cocoa powder while the continuous phase is milk. Cocoa powder is actually hydrophobic and cocoa powder has higher density than milk. Hence, sedimentation occurs and it is driven by gravity. Have you ever wondered why another chocolate milk has no sediment? So, why is it there are two types of chocolate milk selling in the market? First of all, there are two common ways to overcome sedimentation of chocolate milk. One is by addition of stabilizer, while another one is by using finer cocoa powder. The purpose of adding stabilizer is to increase the viscosity of chocolate milk. The example of stabilizer are lecithin and carrageenan. By adding stabilizer, the particles of the chocolate will be trapped and sink slowly. Hence, the chocolate milk will be nice and brown color during their shelf life. In conclusion, addition of stabilizer is to improve the emulsion stability. Lecithin, which is a plant-based stabilizer, is usually added into the chocolate milk. Lecithin is bipolar, which lowers the interfacial tension and interfacial energy by arranging the interface according to hydrophobic and hydrophilic. Carrageenan, which is a type of polysaccharide, can combine with the casein molecule in milk and forming a strong network. It is shown in this picture that carrageenan binds with the casein molecule, fats, and cocoa particles in chocolate milk. By doing so, it is not easy to form sedimentation in chocolate milk. Another way to overcome the sedimentation in chocolate milk is by using finer cocoa powder. As the particle size in cocoa powder is reduced, hence the emulsion stability will increase, as longer time is needed to form sediment. The equation of the sedimentation rate is shown above. First of all, as the differences in density decrease, the sedimentation rate decrease. Then, as the particle size of the cocoa powder decrease, the sedimentation rate decrease as well. While for the viscosity of liquid increase, the sedimentation rate decrease as well. Other than by adding stabilizer as well as using finer cocoa powder to overcome the sedimentation of chocolate milk, shaking is always encouraged by the manufacturer, as shaking is also a good way to overcome the sedimentation of chocolate milk. Addition of stabilizer is to improve the mouthfeel of chocolate milk and to maintain the emulsion stability as well as the suspension of cocoa particles throughout entire shelf life, which includes storage and transportation. Addition of stabilizer is to improve the mouthfeel of chocolate milk and to maintain the emulsion stability as well as the suspension of cocoa particles throughout entire shelf life, which includes storage and transportation.